Imagine you're an astronomer. You spot an object moving in a way no one has ever seen. It's not from our system, it's a stranger, and right now it's threading past our planets. This is 3I Atlas. In the entire history of astronomy, we've only seen 3 such visitors. The first was the enigmatic Oumuamua in 2017. The second, Comet Borisov in 2019. And now, in 2025, 3I Atlas, a cosmic traveler unlike anything we've studied before. Atlas was discovered on July 1st, 2025 by the Asteroid Terrestrial Impact Last Alert System, a robotic sky survey designed to spot dangerous asteroids. At first, it looked like just another faint moving speck, but its orbit told a different story. Calculations showed it was moving far too fast to be bound to the Sun. Its trajectory is hyperbolic, meaning it comes from the galaxy at large, not from our solar system. Later, astronomers combed through archival data and found images of it dating back to May 7th, 2025. With those extra months of observations, they could refine its orbit and confirm this was indeed an interstellar object. Now, here's where it gets fascinating. Most comets arrive on tilted random paths. But 3I Atlas's orbit lies almost exactly in the plane of the planets. Simulation clearly demonstrates this. It will sweep past Mars, Venus, and even Jupiter in a sequence that looks, well, almost deliberate. On October 3rd, 2025, it will pass within about 0.19 astronomical units of Mars, just 29 million kilometers away. In November, it will pass Venus at about 100 million kilometers. By December 19th, it will reach its closest approach to Earth, but closest still means nearly 1.8 astronomical units away on the far side of the Sun. Unfortunately, that makes it nearly impossible to study with ground-based telescopes during that moment. Finally, in March 2026, it will sweep close to Jupiter. The giant planet's gravity will bend its path significantly before it disappears forever into interstellar space. Is this careful alignment a coincidence or something more? The rational answer is chance, but the resemblance to a reconnaissance tour of our solar system has sparked imaginations. So, what do we know about the object itself? Unlike the strangely silent Oumuamua, Atlas is clearly active. It behaves like a comet. Even while still far from the Sun, beyond the orbit of Jupiter, it began to shed gas and dust. That's unusual. Most comets only wake up closer in, when sunlight is strong enough to heat their surfaces. Atlas, however, was already producing vapor. Using the Swift Space Telescope, astronomers detected hydroxyl radicals, fragments of water molecules broken apart by sunlight. From this, they estimate that Atlas is losing about 40 kilograms of water per second. That's roughly 4 buckets of water every second pouring into space. But water is only part of the story. The James Webb Space Telescope revealed something astonishing. Atlas is incredibly rich in carbon dioxide. In fact, CO2 seems to outnumber water by about 8-to-1. This is one of the highest CO2 ratios ever seen in a comet. It suggests Atlas formed in a very cold, carbon-rich environment, perhaps in the outer reaches of its home system. Conditions very different from most comets we know here. Infrared observations also show the presence of dust, ice, and even rare molecules like OCS. Altogether, Atlas seems chemically exotic, carrying a recipe that doesn't quite match our local solar system. What does Atlas look like? That's harder to answer. Its solid nucleus is shrouded inside a glowing cloud of dust, what astronomers call a coma. Estimates of the nucleus size range from just a few hundred meters to several kilometers across. From afar, Hubble images show a kind of teardrop-shaped cocoon of dust, trailing as it speeds through space. And remarkably, its coma glows with a faint greenish tint, likely from carbon molecules fluorescing in sunlight. Polarimetric measurements, basically looking at how its light is polarized, have revealed something never before seen: an extreme negative polarization pattern, unlike any known comet or asteroid. This suggests its dust grains may be very unusual, may be fluffy or structured in strange ways. Whenever we meet an interstellar visitor, one question always arises: could it be artificial? Oumuamua, remember, puzzled scientists because it accelerated slightly without a visible comet tail. Harvard astronomer Avi Loeb famously suggested it could be a light sail or alien probe. With Atlas, the case is different. Its activity is visible. Its gas jets explain its behavior. Its spectrum looks like natural ices and dust. So far, there is no evidence of artificial origin, no strange radio signals, no metallic reflections, no excess heat. Still, some features, like its neat alignment with the planetary plane, keep the debate alive. Whether it's just cosmic coincidence or something more deliberate is left to our imagination. Even if Atlas is just a comet, it is no ordinary one. It is alien material formed around another star billions of years ago. It carries chemical fingerprints of a world we may never see. And now it's here, giving us a brief chance to learn. Unfortunately, comets like Atlas move too fast for us to reach with spacecraft. Designing, building, and launching a probe would take years. By then, the object will be gone. But our current fleet of observatories, including Hubble, James Webb Space Telescope, and planetary probes, are doing everything they can to study it as it passes through. For astronomers, each interstellar visitor is like a free sample from another planetary system. We don't have to go there. The galaxy is throwing pieces of itself our way. So, what is 3I Atlas? A comet, yes. An alien emissary of ice and gas, a time capsule from another star system. In the next few months, as Atlas races past Mars, Venus, and Jupiter, astronomers will be watching closely. Every photon we collect is a clue about how planets and comets form in distant star systems. It's a fleeting chance. By 2026, Atlas will be gone, slipping back into the darkness between the stars. But the data we gather may shape our understanding for decades. 3 interstellar visitors in just 8 years. What secrets will the fourth bring? And when will it arrive?